Okay, so in this video, we're going to look at how to solve a dependent system with one or more free variables. Now, let's consider our matrix, our augmented matrix in the form provided. If you are given a system and they're not telling you that it's homogeneous, you should assume that the matrix system is an augmented system. So in this case, we have 4 columns of variables and then one set of constants. So this matrix is equivalent to the following system where we have x1 plus 3x2 plus 5x3 minus 2x4 is equal to 1. And then in the second equation, we have only 2 variables, x3 minus 4x4 is equal to 3. And then in the final one, x1 plus 3x2 plus 3x3 plus 6x4 is equal to -5. So these are equivalent representations. Now, because there are 4 columns of variables, but only 3 equations, we know the system is probably going to be dependent. It's possible that it could be inconsistent, but an exact single point solution is not going to be possible because we need more equations. We need 4 equations and 4 variables for that to even be possible. All right, so let's go ahead and try to solve this system. Now, to go ahead and solve this system, we're going to need to row reduce this matrix to reduced echelon form. It's important that it be in reduced echelon form when the system is dependent. It actually makes things much more complicated if we only go to echelon form. So if we apply row reducing methods, we really only need 2 steps here. We're going to take the first row and subtract the second row or vice versa. And then we're going to need one more step to get rid of the final set of variables that we have in this second column. So it's very simple. I did the math already, and I got to this matrix. So this is reduced echelon form. Notice we have a pivot, and then a free variable, and then a pivot, and then all zeros. So this is another free variable. So we ended up in this case not with 1 free variable, which would be the case if we had 3 pivots, but we have actually 2 free variables. So in order to finish solving this system, we're going to take the top 2 equations out of the matrix and rewrite them as equations. And then notice again, we have our constants on the other side of the equation. And then we're going to do 2 things. So first of all, we recognize that x2 is a free variable and x4 is a free variable. So we're going to fill those in part 2 by declaring them to be equal to themselves. That way we have x1, x2, x3, and x4 all on the left side of the equation. So a complete vector. So we're going to do that. That's our free variable declaration. And the other thing that we're going to do is we're going to move everything except for the leading variable over to the other side of the equation. So x1 will be by itself, and the 3x2 will become -3x2 on the other side. 18x4 will become -18x4 on the other side, and it'll join the -14 over there, our free variable declaration. And then in this equation, x3 is the leading variable, so x4 is the one that gets moved over to the other side, and then our second free variable declaration. Now from here, we just have to collect the coefficients and the constants together in vectors. So in the first column, we have x1, x2, x3, x4. That's the left side of the equation. That's just our x vector. In the next column, we have -3x2 and x2, coefficients of -3 and 1. Neither of our other 2 equations have an x2, so our vector here for the coefficient for x2 will be -3, 1, 0, 0. When we go on to x4, which is our other free variable, we've got our -18. There's no x4 in this equation. We've got our 4. And then our free variable declaration gives us a coefficient of 1 times x4, so -18, 0, 4, 1. And then finally, the constants, -14 and 3, there's no constants in the two free variable equations, so those are 0. So if this had been a homogeneous problem, we would have only these two vectors as our solution. We would have no extra constants. But because this essentially is a shift away from the origin, because the constants are not all 0, we have our dependent solution plus a set of constants that moves us off of the origin.